Hi, this is Darren with the Mississippi State Chemical Laboratory, and today we're going to do training on our Airbus analysis. Now, this is a special set of analyses that we do for the Airbus company, but really it is just a pH measurement with a twist and a set of special titrations. So we're going to start with our pH analysis. Now, this is mostly the same as our usual pH analysis. You can refer to a previous video to see a more in-depth demonstration on how to use the pH meter in the lab. But the main difference is that we're going to be using a lower set of buffers. So the Airbus samples are both very low pH. So instead of using 4, 7, and 10 to calibrate the pH meter, we're going to use 2, 4, and 7 to calibrate the pH meter. Once the pH meter is calibrated with buffers at 2, 4, and 7 pH, we're ready to do our measurements. So we have our two samples from Airbus. The orange one is what they call allodyne, and the clear bluish one is what they call alumiprep. The pH measurement is fairly straightforward from here. These are both homogeneous liquids, so we just pour them into beakers and then measure them with the probe like we would any regular water sample. Now we're ready to move on to the titration portion of the Airbus analysis. We have two samples and we do each one in triplicate, but the two titrations are different from one another. You can see I have set up here 3 125 milliliter Erlenmeyer flasks for the alumiprep and 3 250 milliliter Erlenmeyer flasks for the allodyne. We are going to put in 5 milliliters of the sample into each of those Erlenmeyer flasks. Now, in order to make the titrations a little bit easier to see, because these are going to be colorimetric titrations, we're going to bring these up in a little bit of deionized water. The exact amount isn't important because we're not titrating the water, but to the alumiprep samples, I'm adding about 25 milliliters of deionized water, and then to the allodyne samples in the larger Erlenmeyer flasks, I will be adding about 95 milliliters of deionized water to bring the total volume up to around 100 milliliters. So now we're ready to titrate, starting with the alumiprep titration because it is simpler and easier, and then the allodyne titration is a little bit more complicated. So we started by adding 8 to 10 drops of what they call indicator 11 into each of the Erlenmeyer flasks containing the alumiprep, and then we're titrating with titrating solution 11. These are all proprietary ingredients from the Henkel Corporation provided to Airbus and then subsequently to us. So we don't actually know exactly what they are, but we can get them through the supply chain. We're going to be titrating from the yellow color where it starts to that bluish color. That's when you know you hit the end point. The titration takes around 30 milliliters of titrating solution. So we use the 50 milliliter burette for this titration. The final part of our Airbus analysis is the iodine titration. It's the most complicated one, but it's still not too bad. So we start by adding in what's called reagent 2. It's about 1 gram of this salt into our Erlenmeyer flask. You can see I took the sample away out of frame. That was to add in 10 milliliters of hydrochloric acid, and then it came back with kind of dark brown color. We titrate with titrating solution 104 until it turns into this lighter straw type color. And then without resetting the burette, add in indicator 10, which turns it to a dark, almost blackish color, and then continue titrating from that point until that dark black fades into a clear bluish color. And this titration takes about 6 milliliters usually, so we're using a 10 milliliter burette for this, as opposed to the 50 milliliter burette that we used for the AlumaPrep titration. After you've done that, it's just a matter of doing it 2 more times, recording your volumes each time, and then we'll be ready to do our data analysis. Okay, so now that we have finished our analysis, we have one last thing to do, which is work up our data to report it. In rows 4, 5, and 6, you can see our iodine data exists. We have the 3 volume measurements we took from the titration, and those 3 measurements get averaged, and that average is what gets reported. So in this case, we have the 6.04. For the AlumaPrep, it's a little bit more complicated. We have our 3 volumes, and they get averaged to the 30.87 in this case, but then we also have a factor of 0.8625 that we multiply the 30.87 by, and that result gets us a percentage, which is the value that gets reported. We also have our pHs here to report, just so that all of the data is together. So thank you for watching. This has been our Airbus analysis for both pH and titration. If you want to see videos that we've done previously on using the pH meter more in depth, or more in depth into titrations in general, you can click the buttons on the screen right now. Have a good one.